There's the card. There it is. Okay. Now, I'm going to ask you one more time. I need you to be very quiet while I'm teaching, and then you will have time at the end to start your certification. We should have plenty of time for that. Is everybody ready? Can't stay in here if you're going to talk. Wait till everybody's ready. All right, so we started out with a baseball analogy, and the baseball analogy was simply there because students, the biggest mistake people make when you ask them for percent is they forget the number one rule. What's the number one rule when you're finding percent? Always divide by the total. Okay, so now you say, well, what's that have to do with chemistry? All right, let's take a look over here. And we said, what does this symbol stand for? You can say water, but how much water? Well, it means two things. It could be in the little world, it could be one molecule water, and therefore that two means two what?
Two atoms. Diatomic atoms.
No. There are two atoms of hydrogen connected to one atom of oxygen. Matter of fact, the two hydrogens are not connected to each other. That's what diatomic hydrogen would be. So in this case, it could mean that. And if I wanted to find a percent by mass composition, I'd say, okay, in the world of mass, the two hydrogens have a mass of 2 AMUs, but the whole water molecule is 18 AMUs, and that's how we did the percentage. Remember this? This is a good review. But what else could H2O stand for? It all could stand for a mole of water, couldn't it? And in that case, what's the 2 stand for?
2 grams.
No, never.
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 What?
Because formulas are always in the world of number of particles.
2 moles.
Right. It's 1 mole of water is made up of 2 moles of hydrogen atoms and 1 mole of oxygen atoms. You get that? So what's the mass of 2 moles of hydrogen?
2
2 what?
grams.
Right. And what's the mass of 1 mole of oxygen? Okay, so 2 grams divided by 18, and you notice we get the same answer because that's what the mole concept does. It takes what's going on in the little world and magnifies it so we can do experiments in this big world, can't we? Moles and grams, we can do experiments. I think yesterday I added something to this. Did I do one where I asked you, oh, I know, it's another page, okay. All right, so then, did you guys do this problem here? We found the percent by mass of in ethanol. Did you guys do ethanol? Okay. Ethanol is an alcohol. We were talking about that. Okay, yeah, you did, because I remember doing this. So anyway, here's the next thing. Here's the next skill that you would have to know, and this is a review. What if I said, I'm going to give you 300 grams of ethanol. Tell me how many grams of carbon are in there. Say, well, how am I supposed to know that? Well, if you look over here, by mass, every bit, a little drop of ethanol or a swimming pool of ethanol is what percent carbon? Okay, so any amount I give you is 52.1% carbon. So what if I give you 300 grams? 52.1% of that is carbon. So I just multiply that times 0.521. Got that? A chemist would use that. I told you about going to the moon or something. If I needed oxygen, there is oxygen in rocks, but it's not breathable. It's locked in a compound, isn't it? But people have actually, did you ever watch the movie called The Martian?
Yes.
Okay. If you watch that, and now you know a little bit more chemistry, you can watch it again, and you'll see where he has a chemical reaction that reacts with some of the rocks. I think it's rocks, and it actually it liberates oxygen gas, doesn't it? Remember that?
It makes plants.
Really?
Oh, wait,
What was that?
wait, not oxygen. I think does he liberate oxygen or is hydrogen?
Oxygen, because he grew plants in there.
I know, but I think also,
He had to do that. He had to like change.
I may have to go back and watch the movie, but there was
Well, you
a,
can watch right now.
I won't, if you have not seen the movie, I don't want to give it away, but something happens, he miscalculates something, and I think he was making hydrogen gas.
The hole punctures in the side.
No, I think, no, I think, no,
It's like
Why
when
are you
he's
trying
trying.
to
wait, there is a hole.
It's
That's
when
it.
he tries to pressurize. He gets inside it and tries to pressurize. it,
Okay.
then something goes wrong. And
All
blows it.
right, so I'm not going to give away the movie, but I believe,
We should watch it.
wait a minute, I believe that he's making hydrogen gas, and he knows how much oxygen is in the tent, so he can actually combine that and make water out of it too. Okay, so that's pretty neat science there, but there's a little miscalculation on how much hydrogen, how much oxygen there is. Something happens. Yes? Okay. All right, let's go down here. The next review we have is a word you've never heard before, and I do have vocabulary words on the next test, so you could probably, that's the easy part of the test, right? That's the easy part of the test.
It's kind of tricky.
It depends, like if you have us right out that.
Like molar mass.
That's really, I mean,
That's tricky.
That was.
All right, here we go. Well then, this must be really tricky. Empirical formula, the reason I need you to know that is that when chemists analyze something, they usually get the lowest whole number ratio, and they had to give a name to that, and they call it the empirical formula. So if you take a look at these are real chemicals here. These are real chemicals right here. But what would the empirical formula be of that? Well, I can't reduce that any further, so the empirical formula for water is the same as the chemical formula. But look at glucose. The real chemical glucose has what empirical formula? You divide all these by 6, and you get there. So the lowest whole number ratio in glucose is for every 1 carbon, you get 2 hydrogens and 1 oxygen. Ready? Yes?
yeah.
All right, next. What about, and I gave away a little money yesterday. What about an ionic?
Oh, those are big bucks.
What about ionic compound?
Zoe, where are your quarters?
So ionic compounds, now this is where I'm asking you to think like a science student, okay? Here, it takes 24 atoms in the right place to make glucose. That's why it's a covalent compound, it's a molecule. There is no such thing as this, but there is such thing as that. And so when you go down here, except for mercury 2 and peroxide, every ionic compound, there is no such thing as a Ba attached to 2 Cls. So here, watch. This would be wrong to do this. It'd be wrong to draw a line and put a Cl, kind of like I did this. This is called these are called ball and stick models. I can do a ball and stick model for water because it really is, those 3 things are attached like that. But those are covalent bonds, and that's what the sticks are. That you can't draw a stick for an ionic compound. There are no sharing of electrons. So this would be wrong. But what you would see, you see a whole bunch of these ions, a lot of them. And then you see a lot of those. There'd be twice as many chloride ions as there would be barium. And so ionic compounds are already the lowest whole number ratio of the ions. So ionic compounds, their empirical formula is their chemical formula. Now I'm just reviewing. This is not new material. You get that?
Oh,
So is this helping?
yeah.
We had this yesterday. So I'm just reviewing this a little bit. All right, let's go to the next part. The next part, this was on page 223. And what we found out was, why do I need to know about empirical formulas? Well, what we're going to do now is, here's one type of problem you might have to solve. What if they give me the grams of one element and they give me the grams of another element and they ask me to find the empirical formula? Number one, absolutely remember, you can never get into a world of formulas if you're in the mass world. What world do you have to be in if you want to get a formula?
Moles.
The mole world or the world of particles, same thing.
Great
So watch
answer.
now. So if I get one of these and you're going to tell me how many grams of aluminum combined with how many grams of oxygen, if you tell me that and ask me for the formula, I know I can't be in the gram world. I must get out of grams and go into moles. Now what's going to happen is, and this is where I used to get stuck when I was really young, I used to get stuck here because I didn't know what to do from this point on. And some of you are going to do that on the test if you don't practice this. You're going to get the moles and you're going to say, well, what do I do? Does this look like the lowest whole number ratio to you? No. So what's that math trick that they've been using for a few centuries? What's the math trick that allows ugly looking numbers to become more whole number looking?
Significant.
Did you guys remember in biology class, I mean Gregor Mendel, did you ever study genetics?
Yes.
And have peas, remember that? Do you know that some people still think that he grew peas and he only had, remember the Punnett square? Did you guys do the little Punnett square? Okay, do you know some people think that square means, well, he only had 4 offspring and one was little t, one was big T, little t, another was big T, little t, another was big T, big T. No, that was a math thing. It says out of every 4, as a ratio, out of every 4, 1 out of 4 will be little t, little t. It didn't mean he had one offspring. As a matter of fact, if you look at his real data, he might have had 950 seeds that he grew. And out of 950 seeds, about 1/4 of them came out to be a short pea plant. There was not one pea plant. It was 1 out of every 4 was short. And Mendel knew how to get the lowest whole number ratio. Okay? Does that make any sense to you, what he said? Okay, so the trick is you take the smaller of the 2 number, or what if I have 5 numbers? You take the smallest of the 5 numbers and divide everybody by that number. Now, unfortunately, it makes it look a lot better, doesn't it? But these still aren't whole numbers. So what do we do with the ratio of 1 and 1.5? How do we make them into whole numbers?
Multiply them.
If you multiply that times 2, it'll make it a whole number, but you can't multiply that times 2 unless you multiply. So now, our final answer is, and chemists, they must have loved this when they first discovered how to do it.
Yeah.
I know how many grams I had, I know how many grams of this came in it, and I finally know what this is. I know for every 2 aluminums, it'll form bonds with 3 oxygens. I know the formula for aluminum oxide. Okay, here's the next one I had, and then we're going to get done with the review, okay? This one had a kind of a twist to it because remember how they had, you had to subtract, they said I had this much vanadium, and then I let it combine with oxygen, and I weighed it again, and it weighed not this much, but it weighed more than that, didn't it? So imagine it weighed, I'll make some easy numbers. Let's say it weighed 0.5 grams. You let it react with oxygen, then it weighs 0.6. Then how many grams of oxygen combined with it? 0.1. Well, that's what you had to do. You had to subtract to get that number. Now I have the, look at me. I have the grams of vanadium and I have the grams of oxygen. Now it's just like this problem, isn't it? See, what you have to understand is you can't sit there and you see one kind of problem. You said, oh, I got to remember exactly how we did that problem. And then you see when it's a little twisted and you said, oh, now I got to remember exactly how. No, you don't. You just have to, if you get to the point where you have grams and grams, you know you can get in the mole world. And what we had up here, we had a 1 to 2.5 ratio, multiply both of them by 2, and that was the empirical formula for that. And that was vanadium 5 oxide. Okay. Are you okay with that? That's review.
Is that the backpack?
And yes? Okay. Now, the reason I review is that to fill in some of the gaps that you might have had from yesterday. So if you had gaps and you were paying attention, you could kind of fill some of those in. I want to show you now the last thing we did, which was the easiest part of the entire day. And this is our last part of review, and I'm going to see if I can blow that up a little bit. Okay, now let's look up here. On the certification, you're going to have 1 or 2 of these, and on the test, you're going to have some of these too. Now, let me show you how to make it easy. Here's the easiest thing you can have. What if somebody else already tells me the empirical formula? Okay, I did an experiment, I found the empirical formula. I did another experiment, I found the molar mass. Okay, you with me? Okay, now, let's say the empirical formula was P2O5. Okay, and another experiment showed me that the molar mass was this. What does that mean, molar mass?
Mass
Of
the mole.
a mole, right? Okay, so the real chemical has this mass. This is simply the empirical formula, isn't it? So how do we know that's not is that the real chemical? You say, well, how am I supposed to know? Well, add up the mass. If you add up the mass of the empirical formula, you get 142. Could it be the real chemical? No, because the real chemical weighs how much?
283.
Okay, so what you want to know is how many of these empirical formulas will fit into that? Or another way of saying it, how many times will 142 go into that one? You see that?
2.
Yeah, 2.
And then all you do is take the empirical formula, multiply everything times 2, and you get P4O10. That's pretty neat. That is the easiest part of the chapter. So if you get a problem and they give you the empirical formula and they give you the molar mass, find the empirical mass, divide it in there, and multiply by whatever number that is. So I want to do that. I want to do that now to get that out of the way. Okay. Now, let's go back and I'll show you a problem that when I was first taught this, I don't think we did too many of these in high school for whatever reason, and I had to do some of these in college, and I really got bothered by it because there were like 13 kinds of problems in this chapter, and I'm in college trying to do these things, and I didn't really understand the mole concept very well. And so I'm having to tell myself, I better remember how to do 13 different kinds of problems. And that was very tense. To me, that was very difficult. But I don't want that to be that way for you. So what I'm going to do is I'm going to give you a problem you've never seen before, and then we're going to see how you can attack it. How can we attack this problem? Okay, let's do, see where it says self-check exercise 8.8? Okay, go ahead and in your notes, and I'd like you not to look at the solution. That's what the book's really good about, though. If you go home and you want to practice a problem, they have a lot of problems with solutions on there. All right, let's try it. Let's give you ask yourself, can I do this problem in 3 minutes? I'll wait till everybody's ready. Now, you'll need a calculator, you'll need a periodic table, and a brain.
Oh, no. Dang it, no. One's off the
I left
table.
mine at home today.
All right, here we go. And I'll start the clock.
Wait, I don't know how to do this.
Wait. You haven't even read it.
Huh?
You haven't even read it.
I read it a little bit.
Now, here's what I'm asking you to do. I'm asking you, as you read it, have your brain think about what we talked about and said, how would I go about this kind of problem? I don't want you to memorize how to do 7 different kinds of problems here. Use what you already know. Okay, let's go. Ready? And I'll start the 3 minutes now. Ready? Let's go. 3 minutes. See if you can have the answer.
Oh, I know how to do this. What is the number?
Can you see it?
Let's keep.
Stop cheating, please.
Can you see it now?
Yeah.
Okay, now get a little serious here because I want you to say, practice for the test on Tuesday. Say, I might have a question just like this. I cannot take 5 minutes to do this problem on Tuesday. Today, all right. I'm all right. If it takes a little longer today, I'm all right. But not on Tuesday.
I can't find Len on the periodic table.
PB.
It's 207.
That, he's playing games.
Yeah. And by the way, just raise your hand. Hey, Freddie, just raise your hand and said which one's lead. And okay.
Well, that's PB, but I can't find it.
Okay. Lead is number 82. So go to number 82.
I got it now.
So what we're doing now is your brain's trying to engage. Say, what do I know about these kind of problems?
But I've already calculated.
Yeah. So if the first thing in your head, when you were reading this problem, it says calculate the empirical formula. If you remember me saying this about 5 times, you cannot do the formula of anything if you're in the grammar, in the math world, right? So you have to get in what world to do any kind of formula? Mole world. Okay? Now, if you did all those problems last week and calculate how to change grams to atoms and moles to grams, and you don't know how to do it, then there's something wrong. So you say, I know what to do. I'm gonna get in the mole world for each of these. Thank you very much.
Oh, got enough.
Yeah,
Oh, I got plenty more.
really?
Long stuff.
Okay, thank
Oh.
you. Thank you.
Why you laughing?
Because he's bored.
Yep.
Oh.
That's right.
Burn.
Sauce on him.
No.
Sauce all over
I'm
him.
interested in this. Stop.
How can you be bored?
No, that was a pun on the.
Oh, that was a pun to
Oh.
the boards.
Oh,
That was a-
I get it.
Hey, on my door, I saw this on the internet, but the original Star Trek, they
No.
have Captain Kirk saying, Scotty, beat me aboard. And then a bunch of wood shows up, and then they have, I don't know if you know about Leonard Nimoy, he was Spock, and he never smiled or laughed, you know, but they were laughing.
Yes.
So, beat me aboard, Scotty.
I haven't watched Star Trek.
I haven't either.
I can
Apparently
tell
it's
you're.
good.
I can tell you're a fan. By the
I'm playing.
All right, here we go. Everybody stop. Everybody stop. Now, right now, you should be pretty much done. So let's see what happened. And if you're not done, find out where you're at. Now, the first thing, I'll show you some of the thing the author got here. So what they got is when you did factor label, they got this many moles of lead. So if you got 0.00667 moles of lead, then that was good. And then you should have gotten 0.00667 moles of, whoops, is this the wrong one? Sorry, wrong one.
Okay.
I'm sorry, wrong one.
I got the wrong answer.
Stop. Sorry, I went to the wrong problem, okay? You should have gotten 0.00332 moles of lead and 0.00662 moles of chlorine. So now you're sitting there and you got these, now remember 3 sig figs, those first 2 zeros don't count, right? Anyway, so you then divide by the smaller and you're gonna get lead is gonna be 1, and what's chlorine gonna be?
1.99.
2. That's gonna be 2, right? And so what is the final answer then?
Lead chlorine with PbCl2.
Wait.
Don't even listen to
Wait.
him.
Okay, every binary compound ends in IDE.
Oh, I was doing like just the.
Okay, so what's-
lead
what-
chloride?
Which one, though?
Lead 2 chloride.
How do you know?
Because lead is because lead's plus 2, chlorine's minus 1. So
Okay, well, first of all, hang on. Well, first of all, take a look. So you should have gotten this right here, okay?
yeah.
And we know that chlorine in a compound is -1, and there are 2 of them. That's why it's lead 2. Isn't that right? That's why it's called lead 2 chloride. All right, well, anyway, that one was kind of a nice warm-up problem. What I'd like to show you here is, I'm going to skip that one, and I'll give you another kind of a problem and see what happens.
Okay, wait. So this was Can you go over that one?
Okay, hey, I need everybody to be real quiet, okay? Did you get 0.00332 moles of lead?
Yes,
Did you get 0.00662 moles of chlorine?
yes.
Okay, so then take the smaller of the 2 numbers and divide both of them by the smaller of the 2 numbers.
Right.
And so this divided by itself is going to be 1, and this is going to come out to be 2. And that means that for every 1 lead, you get 2 chlorines. Okay? All right, so I'm going to show you a problem you've never seen before. I'm going to show you a problem you've never seen before. I'm on page 227. Okay, now, this was kind of neat. And I wish somebody would have taught this to me a long time ago. But it says here the most common form of nylon is nylon 6. And it's 63.68% carbon. It's 12.38% nitrogen, 9.8% hydrogen, and 14.14% oxygen. Calculate the empirical formula. Now, you've never seen this before, okay? You've never seen it. So let me show you a little trick. Let me show you a little trick on this one. Do we know how many grams there are?
Yeah.
It tells.
No, we don't.
No, we don't.
We don't. And we have to get into moles. I don't know how to do percent into moles. So there's a little trick here, okay? What if I gave you a huge amount of this nylon? What percent of it would be hydrogen?
Same stuff.
9.1%, right? 9.8%? What if I give you a little bit of nylon? What percent would be hydrogen?
9
Okay, so they don't even tell me how much they're going to give me, do they? So guess what? I'll pick my own.
Oh.
And here, I'll tell you why I'm smart about this. I'm going to pick, I think they gave me exactly 100 grams. Now, why would I do that? Because then, guess what 63.68% of 100 grams is?
63.68%.
Look at that. No.
No.
Grams.
Wow.
Stop. We're going to stop doing that. We're going to stop doing that. Stop. Shh. Wait. We're going to stop doing that. Okay? That's right. Okay, now, so when you see a problem like this, you simply say, I'm going to assume they give me 100 grams, and then all those percents become grams. Okay, so now, you know how to do the problem? It's just like the last two that we did, isn't it? Change those to what? What are you going to change? 63.68 grams of carbon into what? Moles. Okay, so if you were to look at the, I don't think, let's see if they give the answer here. Exercise 8.10. Okay. Okay, here it is. So if you're interested and you want to go home and see if you got it right, there's the answer there. It says C6N811O. So one more time, if you want to go home and try that one, it's C6N811O. Okay, got it? All right. Now, let's do one more. Let me see if I can find one. I'm trying to find one back here on this page. And then we'll be done with this chapter. Okay, here we go. Okay, everybody ready? See where it says self-check, exercise 8.1? I'm gonna walk around the room, and what you're gonna do is you're gonna try to figure this out and try to push yourself a little bit and see if you can do it in about under 5 minutes for sure. See if you can do it in about 3 minutes. And if you take a look at it and you're kind of lost, then I'll walk around the room and I'll try to get you unstuck. All right, we're on self-check exercise 8.11, and let's go ahead and do that.
What's the 98.96?
Okay, so I'm gonna walk around the room and you can ask me, okay? All right,
What's the 98?
what's it say?
Why? This is the one with mass per watt.
Okay, there's more mass.
Well, why do we get that?
What's more mass? It's units. So what's happening, and when I reviewed today, you're supposed to fill in your gaps.
Yep.
That's not what you were doing. Okay, so you're filling your gaps. We did a problem today, we did one yesterday, did two in a day. Anyway, so what you're doing is, you can get the empirical formula like we've been doing. But is the empirical formula also the real chemical? Well, we'll see. It might not be.
50-50.
Okay, so you get as far as you can, and then when you get stuck, I'll take it from there. Okay, so we just did the empirical formula 3 times, so let's go ahead and do the empirical formula, and then I'll tell you where to go from there. All right, I'm gonna work around. Anybody hand up? Need some help? Remember, I just told you a new trick where if they give me percent composition, they could have given me this much, they could have given me this much. And so I'm just saying, you know what? I think you gave me 100 grams. Do you understand why 100 grams is great?
Yes.
Because what is 71.65% of 100 grams? It's 71.65 grams. And now I know how to change grams into moles, and I'm on my way to do the empirical formula. Okay, so the first thing you're gonna do is take 71.65 grams of chlorine, change it into moles. Then you're gonna take 24.27 grams of carbon, change that into moles. Then you're gonna take 4.07 grams of hydrogen, change that into moles.
Why do you use the 98.96? Like, how do you use that?
You do the empirical formula first, then you can figure out what to do with the other number, okay? So I need to concentrate concentrate when you come to class. And, you know, you can goof around in lunch and stuff like that, but I need you to concentrate in class, because, some of these questions you kind of know. You should know. Again, I think I told you, in my experience when I was younger, I could get to the point where I changed them all to moles. And then I had these three ugly looking numbers looking at me, and I didn't know what to do. What do you do when you have three ugly looking numbers looking at you? What's that math trick that's gonna make it into a more of a whole number ratio? What do you do? Divide by the smallest, okay? I think some of you should, I know you guys are very smart, you're in a higher math class, you should enjoy some of this stuff, using ratios and things. It's how people figure things out in history. Okay, do you have the moles of each? Okay, so I can see a list, where's the moles of everything? Circle them for me, is that it, 2.02? Okay, good. Is that a 4 or 9? Okay, good. So now I have these three ugly looking numbers looking at me, so what I'm gonna do is take the smallest, so divide everybody by that. So you get 1, 2, that's it. Okay, now go ahead and write that down. Normally, in an organic compound, the star of the show is carbon, so usually the order is carbon, hydrogen, and then something else. So if you want to put these in the right order, I'm not going to count that wrong tomorrow, you wouldn't know that. But just if you don't mind, if you put carbon first, then hydrogen, then chlorine, put that in your empirical formula. Okay, so just put CHCl and then put little subscripts down, okay?
What subjects?
See, for every one carbon, there's one chlorine and what? There you go. Okay, now, we're almost done. How many people have the empirical formula so far? Now, I don't have these memorized, but you got C1H2Cl, is that correct?
Yeah.
Did everybody get that? Okay, now, the question is that the real chemical? Well, how much does it weigh? How much does your empirical formula weigh? All right, find that out. Yes?
Once you get like how many moles of each one,
Mm-hmm.
you said divided by the smallest.
So, would you get 2.02?
I got 2.018,
Okay.
and then 2.02, then 0.407.
Okay, so take the smallest and divide everybody by that number.
I got it.
And I think you're gonna get a 1 and a 1 and a 2, I think.
Oh, so now you have to find the percents?
No,
I got
go
it.
backwards. Okay, now, is everybody with me? Does everybody have the empirical formula of CH2Cl?
Yes.
Okay, now how much does that weigh?
49.
Okay, it's gonna be 12 plus 35.5
grams.
plus 2. How much?
49 grams.
It's gotta have a 0.5 in there.
49.5.
49.5? Okay, now, what's the real chemical? How much does the real chemical weigh?
98.
98.96. Well, your
Double
empirical
it.
only weight, so you can double it or you can divide, it's easier to do. So divide this by your empirical mass, and how many times?
2.
So now the real chemical has what formula?
C2,
H, 4, Cl2.
I did.
What do you think? This is pretty neat. What you're learning is what made chemistry advance. The mathematics of chemistry is how they got advanced. All right, so that really is everything in the chapter, okay? That's everything. So what we're gonna do is, I have the certifications ready, and let me show you how this works. I'd like, if you don't mind, since I'm gonna be walking over and over between the desks, if you have book bags, if you wanna put them back there, that would help me a great deal. And then what we're gonna do is, you can have your notes out, you can have your calculator out, you can have whatever you need out, okay? And when I hand this to you, when I hand the certification to you, The number one rule is you're not allowed to ask anybody else for help. I will help you. I will help you. But for me, you don't want my initials on there if you can't do it by yourself. I'll help you, and then you say, now I can do it by myself, and then I'll put my initials on there. Please don't do that, all right? You don't want my initials, you do not want my initials on there if you can't do it by yourself. So just tell yourself, okay, I'm ready to do this. And you have today, and you have and also Friday. Some of it will be done earlier than others. And I want those to be done by Friday. And then you'll get a grade, and get a nice grade for being certified, and you have to be certified. And then on Monday, I'll give you a practice test to sit with people, and then Tuesday we have our test. And I think you can be ready for that. All right, let me get the certification out. Let me stop the video.